What if I told you the entire universe is speaking a language? A secret code that's written in the stars, in the spirals of a galaxy, and even in your own DNA. And no, I'm not talking about some ancient alien dialect. I'm talking about math. We all learn it in school, right? 2 plus 2 equals 4. Boring. But what if that's just the alphabet? What if math isn't something we invented, but something we discovered? Is a triangle a real thing or just an idea? Does the number 7 actually exist somewhere out there in the cosmos? The answer is way weirder and way more important than you could ever imagine. Stick around, because we're about to decode the universe's hidden language. So let's just get right into it. Math. For a lot of us, it's that class we had to suffer through, memorizing formulas and trying to figure out why X is always hiding. But have you ever stopped to really think about it? Where did it come from? Is it a real thing? Or is it just a tool we made up, like a hammer or a language? On one hand, it seems pretty obvious, right? We invented it. Early humans needed to count their sheep or track the days until the next full moon, so they came up with systems. 1 stick for 1 sheep, 2 sticks for 2. Simple. The Romans had their numerals, the Babylonians had their base 60 system, which, by the way, is why we have 60 seconds in a minute and 360 degrees in a circle. It all seems like a practical human invention designed to solve practical human problems. It's a language we created to describe the world, just like we have the word rock to describe, a rock. We have the number 3 to describe 3 rocks. Simple, clean, case closed. But not so fast, because if math is just a human invention, a product of our squishy brains, then why is it so ridiculously good at describing the universe? This is where things start to get a little spooky. Think about it. In the 1600s, Isaac Newton, sitting under an apple tree or whatever, scribbles down some equations for gravity. He invents calculus to make it work. It's all just ideas, right? Symbols on a page. But then, 200 years later, astronomers use Newton's exact equations to predict the existence of a whole new planet they've never seen. They point their telescopes to a specific spot in the sky based on the math, and boom, there's Neptune. How is it possible? How can a bunch of symbols invented by a guy in England predict a giant ball of gas billions of miles away? It's like writing a fantasy story and then discovering it's a nonfiction biography. It just doesn't feel right. This is the core of the mystery. Are we creating the rules, or are we just uncovering a rule book that was already written? Is math the language of the human brain, or is it the language of the cosmos itself? This isn't just a nerdy debate for philosophers. The answer shakes the very foundation of what we think reality is. And look, figuring this stuff out is kind of what we do here. We dive into these huge, mind-bending questions and try to make them make sense. We believe that curiosity is like a superpower, and understanding the world is the ultimate adventure. If you're into that, if you like having your brain tickled, do us a huge favor and hit that subscribe button. It tells the YouTube gods that we're doing something right, and lets us keep making more videos just like this one. It's a click for you, but it's the world for us. Thanks, you're awesome. Now, back to the cosmic mystery. So, let's really dig into this. We've got 2 teams in this cosmic debate: Team Invention and Team Discovery. Let's hear them out. Team Invention has a solid case. They'd argue that our brains are hardwired to see patterns. We see faces in clouds, we find shapes in the stars. We're pattern-seeking machines. So, of course, we invented a system to describe those patterns. Math is our best attempt to create a perfect, logical model of an imperfect, messy universe. Think about a perfect circle. You can draw one. You can describe it with the equation x squared plus y squared equals r squared. But have you ever seen a perfect circle in nature? No. It's a perfect, idealized concept that we invented. The real world is full of lumpy, bumpy, not quite circles.
Math, they say, is the map, not the territory. It's a brilliant and useful map, but it's one we drew ourselves. And there are some heavy hitters on this team. Even Einstein was a bit skeptical. He once said, "As far as the laws of mathematics refer to reality, they are not certain. And as far as they are certain, they do not refer to reality." Basically, he's saying that when math is perfectly logical and absolute, it's just a game of symbols. When it tries to describe the real world, it becomes an approximation, a useful fiction. But then we have Team Discovery. And boy, oh boy, did they have some weird evidence on their side. Let's start with a number you've probably heard of, pi. It's the ratio of a circle's circumference to its diameter, roughly 3.14159, and it goes on forever, never repeating. We use it to build bridges and send rockets to space. But here's the crazy part. Pi doesn't just show up in circles, it shows up everywhere. It appears in the equations that describe the shimmer of light, the ripple of waves, and even the distribution of prime numbers. A physicist named Eugene Wigner called this the unreasonable effectiveness of mathematics in the natural sciences. It's just unreasonably good at its job. Why would this one number, this one ratio, be so fundamental to the universe if we just made it up? It's like we invented the key and it just so happens to unlock 1,000 different doors we didn't even know were there. And it gets weirder. Let's talk about prime numbers, numbers that can only be divided by 1 and themselves, like 2, 3, 5, 7, 11, and so on. They feel random, right? There's no obvious pattern to where the next one will pop up. For centuries, they were just a mathematical curiosity. But guess what? Some species of cicadas have life cycles that are either 13 or 17 years long. Why? Because those are prime numbers. By emerging only every 13 or 17 years, they make it really hard for predators with shorter life cycles, say 2 or 4 or 6 years, to sync up with them. These insects are using prime numbers for survival. Did the cicadas invent prime number theory, or are they tapping into a deep, pre-existing mathematical truth about the universe? This is the argument from Team Discovery. Math isn't a language we invented, it's a fundamental aspect of reality that we are slowly, painstakingly uncovering. The universe, at its most basic level, is structured by mathematics. The laws of physics are just mathematical equations. The energy in an atom is described by E equals mc squared. The force of gravity is a beautiful formula. These aren't just our descriptions, they are the thing. The universe doesn't just obey mathematical laws, it is mathematical. Think about fractals. Like the Mandelbrot said, this is an infinitely complex, stunningly beautiful pattern generated from a very simple equation. Zn plus 1 equals z squared n plus c. Before computers, no one had ever seen it. We didn't design it, we just plugged a simple equation in and hit enter. And this entire universe of infinite complexity revealed itself. We didn't invent the Mandelbrot set, we stumbled upon it. It was always there in the abstract realm of mathematics for someone to find it. So if we didn't invent it, who or what did? So, where does that leave us? Is math a tool we built, or a universe we found? Maybe the answer is both. Maybe the distinction is a false one. Think of it like this. Our human brains evolved in this universe, subject to its laws. So it makes sense that the logic our brains developed would mirror the logic of the universe itself. We didn't invent the concept of gravity, we observed it, and then created a mathematical language to describe it as accurately as possible. The universe provided the grammar, and we came up with the alphabet. Maybe mathematical concepts, numbers, shapes, formulas, exist in some kind of abstract, non-physical reality, a realm of pure ideas. Plato thought so. He called it the world of forms. In this view, a mathematician is more like an explorer than an inventor. They are charting a new continent, mapping out its features, discovering its strange creatures and beautiful landscapes. The continent was always there. We just needed to build the right ships to get to it. This leads to a truly profound conclusion. If math is a universal discovery, then any intelligent life out there in the cosmos would almost certainly arrive at the same mathematics. They wouldn't have 10 fingers, so they might not count in base 10, but their value for pi would be the exact same as ours. Their prime numbers would be the same. The Pythagorean theorem would still hold true on their planets. Math could be the ultimate universal language, the one Rosetta Stone for communicating with any intelligence, anywhere, anytime. In the end, the question, is math real, pushes us to the edge of what we know. It forces us to ask what real even means. Is an idea real? Is a law of physics real? What we do know is that this language or discovery has given us the power to understand the world, from the tiniest quantum particles to the largest superclusters of galaxies. It has allowed us to build civilizations, cure diseases, and reach for the stars. So the next time you see an equation, don't just see a boring school problem. See a sentence in the universe's native tongue. A sentence that was written long before we were here and will remain long after we're gone. We're not just learning math, we're learning to read the source code of reality itself. And that is an incredible, mind-blowing adventure. What do you think? Are we inventors or explorers? Let me know your theory down in the comments. I read as many as I can, and this is one of those topics I could talk about forever. If you enjoyed this little trip into the cosmic code, please give this video a like, and if you haven't already, consider subscribing. We have so many more mysteries to explore together. Thanks for watching, and as always, stay curious.